Okay, let me talk through a few things here, all right? When we look at question 9 here, because a few folks are still having questions with it. All right, first thing you need to be thinking about here, right, is when we look at our options here, right? Where's my pointer here? Should be enter. Oh, all right, there we go. All right, so if you look here, right, we get our scale here. 5 meters equals 10 centimeters. And so that's the key thing here. That's our first ratio we're looking at here, right? Now, if we look at it, right, there's our scale at the very bottom. 5 meters to 10 centimeters is a ratio, right? Think about that. If we think about our ratio here, right? Remember, ratios, just like fractions, should be simplified when possible. So if we have 5 meters over 10 centimeters, well, guess what? We simplify it, right? And so thus our new scale is 1 meter equals 2 centimeters. Again, don't overcomplicate the system if you don't have to. So there's our scale. That's our big thing right there. That's the starting point. If we want to find this room, the bedroom, we got to start with our scale. All right. Again, don't get distracted by the big drawing. The problem tells us that on the drawing, the bedroom is 6 centimeters by 5 centimeters on the drawing. To find the real world area, we need to convert both dimensions to meters and then multiply them to get the real world area. So again, here's our drawing here, right? Here's our drawing. Let me go get my pointer, the laser pointer. So 6 centimeters, 5 centimeters. All right, on the drawing. Now, if we look at our scale in the bottom left corner there, 1 meter equals 2 centimeters. So we got to figure out this 6 centimeters here. How big is that in meters? Because if you have a room that's 6 centimeters big, you can't fit in it. So we want to know what the real world size of that room is. And so if we look at this, right, 2 to 6. Well, 2 times 3 is 6. So if I multiply the bottom by 3 and the top by 3, because whatever you do the bottom, you can do the top, I could solve this with similar fractions and get 3 meters for that side. So up here would be 3 meters. Likewise on this side right here, 2 to 5, well, 2 times 2.5 equals 5. Now, if you can't see the similar fraction, well, then let's go to our next slide, because other ways to solve it. If you notice here, I got rid of our units here. I said 1 to 2, and then our unknown number of meters to 6. You've seen problems like this. Well, one way you can solve it, well, isolate our variable m. Multiply both sides by 6. What do you do on one side of the equation? Oh, the equal sign you do on the other. So we get 6 over 2 equals m, 3 equals m. And so here's that 6 centimeter side, that's 3 meters. If we think about the other side, 1 to 2 is the same thing, m to 5. If you don't like the whole multiply both sides by, like I could done by 5 on this side, but if you want to, you can do cross products. I mean, so you could solve with similar fractions. You could solve it by multiplying both sides by 6. Or on this side, you could say, hey, cross products. 2 times m, 2m. 1 times 5 is 5. 2m equals 5. Divide both sides by 2. So m equals 2.5. And then we go to our final answer here. 2.5 meters times 3 meters equals 7.5 square meters, which again is that room, the room here, the meters, how many square meters for that room. And so hopefully that clarifies it a little bit better. All right, let's see how that does.